x, right?
Yeah, x.
Plus b. So where y was response, okay, x was predictor, predictor, and b was coefficient, a was coefficient or constant, whatever you can say. Right? But for the multiple regression, the formula is y equals to ax1 plus bx2 plus cx3 and so on plus b, where a, b, c, d all are your coefficients, okay, and x1, x2, x3 and so on is your
predictors.
And then what is y? Y is the response. So it means, say that if something is depend on the more than one predictor, okay, so that you have to define as a x1. So let's take one example. If a salary of an employee is directly proportional to years of experience, right?
Yeah.
Then domain, then institution, they have studied institutes, right?
Yes.
And then what is, as well as the location is also matter, right? And some others, right? So salary of employees matter on this. Years of experience is lesser years, so salary is lesser. If the domain is some kind of a niche domain, okay, then salary is higher. If institution like grade A institution like IIT, NIT, kind of that, or any BITs, then the salary will be high. Or this is assumption, it's not always true, but it's an assumption. The location, if the location is the best place, suppose that the location is Bangalore, then probably the salary will be high. If the location is Mohali, then probably the salary will be less, right? If the location is USA, then probably the salary will be high, right? So that is also related, and so on. So then you have to define x1 like years of experience, then the x2 like the location, right? Then the x3 like basically the institute, and so on, right? So let's take that this examples, or another example could be like that, vehicle mileage maybe depends on what, particularly that engine capacity,
yes,
in the cc, right? Then the horsepower, right? Then the liter of engine, so whether it's a 1.1 liter, 1.6 liter, 2.0 liter. Then whether it's a type of the oils, like whether it's a diesel or the petrols. If the petrol, then the mileage is lesser. If the diesel, the mileage is high, and like so on. So basically, then you have to put these formulas. So instead of here, so you can put that cc. Then here you can put like a HP. Then here you can put like anything, right? So now let's take this one, that example. So we will learn today multiple regression. Not required. So So the multiple regression, I mean regression is what? The regression is the analysis.
The relation between two variables.
Basically the relation between the what? X and Y. Right. So X is your predictor and the Y is your response. So one of these variables is called the predictor and the others is called the response.
Yep.
So then what is a multiple regression? So multiple regression is an extension of the linear regression. Right? You can say it's the next stage of the linear regression into the relationship between the more than the two variables. Alright. Now in the simple linear relations we has one predictor and one response variables, but in the multiple regression we have more than one predictor variables and one response variables. Right? So that the formula is something like this.
Yep.
A plus b1 x1 b2 x2 and then so on. Right? So here in this example, right? So y is equal to a plus b1 x1 b2 x2 and so on. So where the y is response, right? A, b1, b2 is your the coefficients, x1, x2 is your predictor.
Yes.
Right. So now, so to get at the multiple regression, okay, we will use the LM formulas. Right. So always, whether it's a linear or the multiple, we will use that LM formula. Right. LM function. But the input will be the different for linear regression or multiple regression.
Yeah.
Right?
Yes.
So if it was if it is a linear, then the function was what?
Y tilde x.
X. Right? So if it is this is a linear regression. Right. So if it is multiple regression, then basically the y is depends on what are the limit. You are the x1, right? x2, and then your final the data. That's basically the data we passed.
Yeah.
Right. So in this case, so these are the two part. One is that this is your what? This is your formulas. So this is your formulas and this is your data. Right? So what was the formula saying here? So formula is basically nothing but a symbol represent that relationship between your y and x. And the data is a set of the data where we are working on. That is again this data is what? This data is a sample data. Again, this data is sample data. And then the accuracy is depends on the sample size. So the sample size is more. Okay. So the error is what? Indirectly proportional.
Yes.
Right. If sample size is less, error will be high. Error is high. Right? If the sample size is more, error is less.
Yeah.
Right? So now okay, so here we consider this one vehicles. So consider the data set empty cars. Basically it's already available data sets available in the R environment. It gives a comparison between the different car models in terms of mileage per gallon. Alright. And then the cylinder of the displacement, what is the cylinder of the displacement, then the horsepower, then the weight of the car is also measured for the speeds, right, and some other parameters. So the goal of this model is to establish the relationship between MPG as a response variables, okay, with response to your displacement, horsepower, weight, then that your CC, engine CC, engine liters, there is plenty of the others variables. Okay, so we'll create like that. So let's take example. So I will get clear. So I will get this variables. So in the variables, what I am getting MPG, displacement, SP, horsepower, and then weight as an input. Right? So here, if I print input, I will get that huge data with all those details, right?
Yeah.
So if I get that, okay, at least the header only, print head input.
The first
So
6.
Yes, first 6 with that, okay, displacement, MPGs, HP, and all those things. Right? So that's the first 6 elements. Now then.
So 1 second. In the sentence, empty cars, open braces, there is a comma first. So why they have mentioned? So before C.
Yes, so this one, right?
Yeah.
So this is saying that, okay, the element is maybe the mode.
Okay.
Right, but we will take that only this one. Okay, so now this is basically we have taken that input data, right? Now we will take that, okay, what is the process, right? We have to create that relationship. So we have this input, right? Now we have to create that model, right? So
Yeah.
again that the model. So this is the data. So this is, okay, basically the top 6, and this is the model. So model is that what? This is your MPG, that is nothing but your Y, right?
Yeah.
Then the displacement plus horsepower plus weight plus this, and then data is equal to input. So that the input data is this one that we have taken from this empty car system.
Okay.
Right?
I think in previous examples we have not declared the data.
Yes.
In
Yes, that is X.
Oh.
I'll show you. That's an X. Okay, let me check whether I have data or not.
It's the
See,
yeah.
right? X,
Yeah.
right?
See. So X is nothing but like is data in that example. So here we are declaring data.
Data set, because it's a set. Yes. Okay. So now we created the model. So let's see that what is there in the model. Again, that okay, all those details, right? What are the okay, formulas is this? Then what is the okay, coefficient is this for the displacement, SP, and weight. Right?
Yeah.
So once we created the input data, then we have created the model, that is a relationship. Right? Then what the next we have to figure out that coefficients and all those things. Right? To get the coefficient, so how many coefficients we will get here? We have to get all those 3 coefficients. Right?
Yeah.
So
The summary is it?
yes, so the one is coefficient from the model, right?
Yeah.
From the model of first element x1. Okay, let me check whether it's getting any error. No, so that is basically 37.105505. Okay, then again for displacement. All right. So then coefficient of from the model, basically we can say that coefficient from the model of the second element, right? Then for the HP, again the coefficient coefficient from the model of third element, right?
Yeah.
Then what is the for the weight?
Weight.
X weight, coefficient from model of fourth element. So as like if we have a predictor more than 4, 5, 6, 10, so we have to put like that, okay? And once it's done, then okay, we can print, we can check that print also. X displacement, yes, I am getting. Okay, so print X HP, yes, I am getting, right? And then print X weight, right?
Yeah.
Yes, I'm getting.
So if you want to print all together at once,
It's you can print. Just try to print this, print this, print this. Hit enter.
no, is there any like a special keyword for
No, that's special. You know, see here.
So can we use coefficient of model?
No, see.
Okay.
I have written down all those three print statement also. Hit enter. So you will get all those.
But thing is like not like this. So I wanted to print like using only coefficient and then model. Can I get all those details? Okay.
Okay. So now what else? You have a data, you have a model, you have a coefficient. What else?
So you want the result?
No. That's a question data, right?
Yeah.
So what was the question data? So if I give you that displacement of this, then the horsepower of this, weight of this, then what will be the mileage, right? So that is basically nothing but your input data.
Yeah, that is input. So whatever the now we
Right.
given those are.
Okay, so once we given that input data, we have to apply these formulas.
Okay.
A x displacement multiplied by x1 plus xp, that is a coefficient, right? x2 coefficient x3, right? Or you can directly, because you know that you have a data of the coefficient, either you can directly put that formulas. Okay, so what I do is just I will take this example because I have all those coefficient. Okay, so what is differences? It will be the small x, small x, small x. So we'll use this formulas, right? So now if I will hit now, I will get that error.
Yeah, not found.
What is not found? X1.
X1.
That is the displacement where we will calculate the data and we will predict the formulas. Right? That is not available. Right? So
those details we need to declare it.
Yes, we have to give something like this.
So x1, x2, x3 as a
so
like.
x1 is this one, x2 is this one, x3 is this one. Right?
Yeah.
So you can put like x1 equals to what? 221. x2
102
equals to 102, right? x3 equals to 2.91, right? Now then apply your formulas. Which formula? This one.
there, yeah, y.
Right?
Yeah.
So now you will get the x
Object x display. Just go back and see what have we declared x display. So
basically it's taking some other difference.
yeah, now it is taken.
That's dot was saying that okay, object.
Okay.
Right, so it's basically nothing but a multiplication. Right?
Yeah.
So then you have a y. So then you can print that y. So that's the mileage will be the 22 point something. That is again, this is just a prediction that okay, then your mileage will be like this.
Okay.
Close.